Okay, find the numerical values of the roots, deduce the value of k. Solution. So first thing to do is to write out the given cubic equation, which is given to be x cubed minus 21x squared plus kx minus 216 equals 0. Then you compare this with x cubed minus summation alpha x squared, then plus summation alpha beta x, then minus summation alpha beta gamma. So when you compare that, you realize that sum of the roots is going to be 21. Then sum of the pair of any roots, that's going to be k. Then the product of the roots is going to be 216. Okay, now that we have this thing, so let's start with each of this. From the first one, which is summation alpha equals 21. So remember that the roots are given to be ar and ar is power minus 1. So ordinarily we use alpha, beta and gamma. So but since our root is this, so that implies that alpha is a, beta is ar, while gamma is going to be ar to the power minus 1. So when you make the substitution here, which is the sum of the roots, alpha plus beta plus gamma equals 21. So this becomes a plus ar plus ar raised to power minus 1 equals 21. Okay, so if you look at the left hand side of the equation, a can be factorized. Then we're going to have 1 plus r to the power minus 1, then equals 21. So let's call this to be equation 1. So we take the second expression, which is sum of the pair. That is summation alpha beta equals k. So this can be written as alpha beta, alpha gamma, then beta gamma equals k. So we do the same thing by substituting alpha to be alpha, beta to be alpha to be a, beta to be ar, and gamma to be ar to the power minus 1. And that's going to be a in brackets ar plus a in bracket of ar to the power minus 1, then ar in brackets ar is power minus 1 equals k. So in simplest sum, this is going to be a squared r plus a squared r to the power minus 1 plus a squared equals k. And of course, a squared can be factorized a as well, and that becomes a squared r plus a squared, then we have r plus r minus 1 plus 1 equals k, where this as well can be rearranged and be written as 1 plus r, then r to the power minus 1 equals k. So let's call this to be our equation 2. Okay, now we consider the last expression, which is this product of the roots. So for the product of the roots, we have summation alpha beta gamma, that is given to be 216. So alpha is a, beta is ar, and gamma is ar to the power minus 1 equals 216. In simplest sum, this becomes a to the power of 3 equals 216. Alright, so when you take a root of both sides, you're going to have a to be 6. Okay, so the other roots there are imaginary, and we only need we only need real roots here. Okay, so that's why we only consider a to be 6. Now that we've gotten a to be 6, we need to find the numerical value of the roots. So for us to get the numerical value of the roots, which means that we've gotten one of the roots to be 6, for us to get the value of ar, we need to find r. Then likewise, to get the value of the beta, which is ar raised to power minus 1, we also need r as well. So what happens next? So we can just make substitution of a equals 6 in equation 1. So that is substitute a equals 6 in equation 1, and from there we have equation 1 to be a in brackets 1 plus r raised to power minus 1, then we have 21. Okay, so this is 6, 1 plus r to the power minus 1 equals 21. Okay, so what happens after this? You divide both sides by 6, so you have 1 plus r to the power minus 1. 27 divided by 6 will actually give us 7/2. Okay, so don't forget r to the power minus 1 is same thing as 1/r. Okay, so what happens next? You multiply both sides by 2r, and when you do that, you're gonna have 2r squared plus 3r minus 7r plus 2 equals 0. So I've brought 7th r to the other, to the left hand side. Okay, now from here, this is gonna be 2r squared. 3r minus 7r is 4r, or minus 4r. That should be minus 4r. Oh, sorry, where we have 3r here should be 2r. Okay, and this is now 5r, then plus 2 equals 0. And this will give us the value of r is going to be 2 and 1/2. So when a equals 6, so the first time we have the roots are ar raised to the power of minus 1. So you can use any of these values of r, either 2 or 1/2. You still have the same roots. So when a is 6 and r is 2, this is going to be 6, 12, and then 6 times 1/2, that's going to give us 3. Okay, so which means that the root is going to be 3, 6, and 12. So if you still take r to be 1/2, I'm sure you're going to have this, so you can confirm that after the class. All right, so the second part of the question, we have to deduce the value of k. So we don't need to bother ourselves again, so that is where equation 2 comes in. So we can just make use of the results we've gotten in equation 2, which is this. This is our equation 2. Okay, so from 2 now, we've gotten a to be 6, so we have 6 squared, then 1 plus, like I've said, you can use any of the r, either 2 or 1/2, so I'm using 2 now. So this is 2 plus 1/2, then equals k. So finally, you obtain k to be 126. So if you do your math or calculation very well, and that is the end of the solution. Okay, thank you.